If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I will be one of your hosts this evening. My name is Hugh Podmore, and I am joined by Paul. Are you there, Paul?
Yes, indeed. Good evening, everybody.
As well as Julie.
Hi.
We are broadcasting live from the York University Astronomical Observatory located in Toronto, Ontario, Canada. And this is Astronomy Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 1 a.m. Universal Coordinated Time. And the York Universe production works in concert with, and most nights work in concert with, our online public viewing program, which sadly tonight is not functional. So I'm afraid that the online public viewing program that we run in conjunction with the radio, in which you can view the live images from the observatory at York University, is sadly not functioning tonight, which is a shame because it's lovely clear weather, I believe. Yes. At any rate, our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you may have of past shows, if you have suggestions for future topics, please check out our newly refurbished website, yorkuniverse.com, or follow us on our Facebook page, or tweet us on Twitter at YorkUniverse. We'll be monitoring the Twitter feed, I guess not the chat room tonight, but we will be watching there for your comments, your tweets, your favorites, and everything you would like to let us know. So, how is everybody tonight?
Doing good.
Yeah, I was doing great until all sorts of gremlins invaded the York University Observatory. And it's one of those things.
It's sort of disappointing, really, because it's been pretty nice weather recently.
Well, it has. In fact, last week was the first operational week for our new 60-centimeter telescope. As our listeners will probably recall, been talking up the modifications, the stepper motor inclusion into the 60-centimeter drive system so that we can now fully computerize the telescope. And last week saw 3 nights of data collected, which was the first time since basically the springtime. So we were all very excited. That went very well. Tonight's observing team started out, and as would have it, nice clear night. Gremlins entered the system. First the hand paddle wouldn't work, and then it did. And then the computer system didn't want to behave itself, and then it did. And after a degree of frustration, obviously it slopped over to the Adobe Connect classroom protocols, and we couldn't even get up OPV. So I have half a dozen very disgruntled observatory team members tonight at York.
Oh, dear.
Yeah, it happens, and as you said, it's clear.
Is there any chance for them to get it fixed, at least so that they can see some things for themselves, or are they done until tomorrow?
I think they were heading off to find some suitable libration somewhere and go next time. They've been hard at it for the better part of 3 hours, and so at some point you go, it's just not meant to be.
All right. Well, we are happy for their effort, and hopefully they'll be returned to us next week with some fancy new telescopic images.
I think it's all the Big Bang's fault, personally. It was their premiere episode tonight, and everybody was sidetracked. All of the York University computing staff are off watching the Big Bang, and they're just not paying attention to their service. That's my pet theory.
All right. Well, we'll have to figure that out next week when they come back.
Absolutely.
At any rate, we'd like to start this show, as we start every show, with This Week in Space and Astronomy History. And our first story for this section comes to us from Julie.
Yeah, so Johann Gottfried Galle was a German astronomer working at the Berlin Observatory, and on the night of September 23rd in 1846, working with the assistance of Heinrich Louis Darret and using calculations made by the French mathematician Urbain Le Verrier, he observed Neptune. Observations were made over the next several nights that would confirm that the object was a planet. And interestingly, Galle refused to be acknowledged as the discoverer of the planet because he was just looking where Le Verrier asked him to. Le Verrier specialized in celestial mechanics, had been looking at perturbations in the orbit of Uranus. Although Galle did make several other discoveries during his career, including a dark inner ring in Saturn's ring system and 3 comets, which were discovered between December 1839 and March 1840. Also, interestingly, just one more thing, the anniversary of Le Verrier's death is in 1877 is tomorrow.
Oh.
So the same day.
How about that?
Several years.
If you enjoy astronomy,
set up in front of the Stacey Library and the Scott Library, showing you some of the really neat things. We're going to make a comet. We're going to be doing a little bit of crater demonstrations. There'll be a lot of interesting literature that will be handed out during these events in and around the lunch hour. And then on Wednesday, Dan Falk is coming to give a presentation in the afternoon, and he talks about science and Shakespeare. So it's a really nice blend of what is often thought of as the pinnacle of English literacy, but there's a phenomenal amount of really great astronomy in Shakespeare's work. So there will be a real nice crossover talk on the Wednesday afternoon. So that just gives you a bit of a sense of how the various libraries are engaging the public, trying to show them things as well as create this crossover climate, shall we say, for people to marry together science as well as the humanities. So good stuff. If you're in and around York University Tuesday and Wednesday of this week, please by all means drop in on those events. So I thought I'd just pass that on here. Okay, for those of you who missed it, summer is on its way out. Now, there's all sorts of terrific stuff on radio at the moment about the summer that never was. Personally, I like the summer. I don't like getting suntan because I sunburn. So as far as I was concerned, summer was nice, but I'll get a lot of hate mail for that. Regardless.
I agree with you, Paul.
Thank you, Julie. What can I say? It was nice. My grass didn't die. My lawns grew really well. Anyway, whichever way we like it or not, summer is en route out of here. Tonight at 10:29 local time, the spring equinox, the fall equinox, the autumnal equinox takes place. And we will transition from summer to fall in this hemisphere, which basically means, of course, the days are getting shorter. And after today, the amount of darkness is longer than the amount of daylight. So, that's not necessarily good news unless you're an astronomer. We think it's great. But of course, in the southern hemisphere, the opposite is happening. We're transitioning from winter into spring. And so I can tell you right now that my parents are really happy about that, living in Australia. So, it depends which part of the planet you're in, whether or not this is a sad event or a happy event. From the astronomical point of view, it is the moment that the sun crosses the celestial equator as it moves across the sky, moving from the north celestial sphere, hemisphere, I guess, to be more specific, down to the south celestial hemisphere. So we're in this ecliptic path. That's the path that the sun moves across the celestial sphere, and we're moving from the north to the south. Of course, this situation will carry on. That is to say, the sun will continue this southward migration until the December solstice, the beginning of winter. At that point in time, it will stop heading south. It'll begin heading north again. And of course, the days will begin to get marginally longer at that point in time. So, fall is in the air after 10:29 p.m. this evening.
All right, and I bet you are also looking forward to the extended amount of observed time that we're going to
absolutely. Yep.
Well, I think we all are, especially our listeners, as soon as the OPV gets back up and running.
Well, that's exactly right. The team was getting very excited about doing all sorts of things tonight, starting off the new year, shall we say. It just didn't quite happen the way we wanted. But anyway, they'll be back firing on all cylinders next week, and it'll be, quote, deep into fall by that point.
Sounds good. Well, speaking of firing on all cylinders, our next news topic is, of course, the very exciting news from NASA regarding Boeing and SpaceX, which Julie is very eager to present. So, Julie?
Yes. So Tuesday, NASA announced that the $6.8 billion contract to ferry astronauts to from the International Space Station has been awarded to Boeing, $4.2 billion of that to Boeing, and to SpaceX, with the remaining $2.6 billion going to them. This would end the American dependence on Russia to get the crew to the space station, which at the moment is awkward and also expensive at $71 million per astronaut. NASA hopes that the two private companies will be ready to start missions in 2017. The Boeing capsule is called the CST-100, and the SpaceX is the Dragon, and they'll have to pass rigorous safety testing in order to gain NASA certification for human space transportation systems before launch dates can be set. And NASA's hoping that handing transportation to the ISS to private industry will free them to put people further into space, like the moon or Mars or elsewhere.
Yeah, right. That's because President Obama, I think in 2010, set perhaps a fairly soft mandate, but a mandate nonetheless, that NASA should be aiming to get people on Mars in and around 2030. So hopefully, if NASA's not required to focus on getting the astronauts to the ISS all the time and getting cargo to the ISS, then they can put all the effort into developing their Orion capsule, along with the Space Launch System, which is, of course, their new mega rocket, which is going to be able to ferry crew and cargo much further out. The Space Launch System and Orion are actually really exciting. Orion is going to be launched this year in its first unmanned deep space flight. That'll happen in December this year. And the Space Launch System, although we don't know when that will be specifically launched, we do know NASA has just unveiled part of its toolkit to assemble the Space Launch System. And that is the largest welding device that's ever been built. And I've seen pictures of it. It is huge. It is 170 feet tall. And it's going to be used to weld together this 200-foot tall core stage for the Space Launch System. So, with SpaceX and Boeing taking the pressure off of NASA to take people up to the ISS, we can focus more on getting this Space Launch System, which will be a phenomenal and formidable piece of engineering up off the ground. So I'm very excited about that, and also quite happy to see that SpaceX has received the essentially what it set out to receive in terms of funding for its rockets.
It's actually been a fairly good week for SpaceX in that regard. The announcement last week of this funding, as you indicated, what they asked for as far as getting their Dragon capsule man-rated, if that's the term which is still being used. And, of course, they launched to the International Space Station last night with their next cargo flight. The whole SpaceX story has been one of considerable success, or at least in my eyes. It's on a timetable which is pretty ambitious for the private sector, and there's been lots and lots of good things to be very pleased about. They have lost the occasional vehicle, although none to the International Space Station at this point in time. I think they lost one of their sort of Grasshopper test vehicles a few weeks ago in a bit of a blaze of glory. But
successfully tested the fail-safe devices.
Is that what it was? Oh, that's what you call spin, if ever I heard it. Okay, but nonetheless, SpaceX has been a terrifically positive story. I just continue to marvel at the slow rate at which the US has pushed the envelope of getting back to Earth orbit for human beings. I look back at the similar time frame in the 60s. And, we went from John Glenn and 6 years later to just about Apollo 8 orbiting the moon. John Glenn, 3 orbits around the Earth, and barely 6 years later, 6.5 years later, Borman, Lovell, and Anders orbiting around the moon with Apollo 8. In the same time frame, NASA has managed to go from no shuttle system to an Apollo capsule on steroids, taking astronauts back to the International Space Station. I mean, that to me is remarkably poor, without me saying it too loudly. But I mean, I'm glad we're almost back in business, but it's been a slow grind the 3 years, and they're forecasting another 3 years. I just find that amazing. And as you said, Julie, the only show in town has been Soyuz, and they've jacked the prices up from 25 million a seat to 71 million a seat, and that's only assuming that they're not too displeased with international politics, aka Ukraine and so on. Oh, I find it a remarkable story. I really do.
Yeah, well, I mean, the nice thing about private space isn't it tied to the sort of government funding cycles as directly as NASA is. NASA has to fight for their budget every year. But SpaceX, once they've got a contract like this contract, it's locked in. They can count on that level of funding for the years that it's set out for, which gives it the opportunity to do the kind of long planning that NASA sometimes isn't able to do because they have to fight for the budget every year.
No, you're absolutely right, and NASA giving off the low Earth orbit business to the private sectors is freeing them up to look further afield. It's just, to me,
Too slow.
it's an unsatisfying pace, and there's nothing we can do about that, of course, in this day and age. But it doesn't stop me feeling unsatisfied about the whole affair, and I'm sure that's reflected by everybody at NASA, even though they don't say that. Once Orion flies this December, if it flies successfully, and have you heard a date, Hugh, as far as when SLS/Orion will take humans back to space?
So they won't fly together until 2017 or 2018, but we don't know exactly when.
Okay, so
that would be so it's slow pace, but we're getting there. At any rate, a good week for SpaceX, presumably a good week for Boeing as well. So good week for SpaceX, good week for us. Also, as Julie will now report, good week for Mars.
Yes, I don't know about you guys, but this time last night, my Twitter feed exploded with Maven. The Maven spacecraft successfully entered Mars orbit last night at 10:24 Eastern Daylight Time, and is now in a 6-week-long commissioning phase, during which it will maneuver into its final orbit around Mars. The science mission of the spacecraft is to study the atmosphere of Mars and the effects of the sun and the solar winds, the effect that those have on it, in the hopes of learning more about the conditions that took Mars from being a warmer, wetter planet that it was in the past to the dry planet that it is today. And kind of a serendipitous timing, I suppose. On the 19th of October, coming up, comet sliding spring will pass close enough to Mars that the atmosphere of the comet will interact with the atmosphere of Mars. And Maven is in a position to give us an unprecedented opportunity to study this interaction.
So, Julie, just before you carry on with sort of the part 2 of the Mars update, in your readings, have you seen very much concern associated with the passage of comet sighting spring and the Mars orbital fleet? I mean, it's not going to impact anything on the ground, but there's 3 or 4 satellites that could be, I don't know whether endangered is the right word, but impacted, shall we say?
Yes, because at the speed that things will be moving, even millimeter-sized things could cause some damage to the spacecraft, which will be hiding out on the other side of the planet or something like that.
That's a good term for it.
It was, well, I saw it in a video, which we'll link to in the show notes. But the graphics sort of showed the 3 NASA satellites that are currently on orbit, just hiding behind Mars. The comet goes on the other side.
Mm-hmm. Well, if they had the choice, I think that'd be a really good plan. But of course, they won't necessarily have that choice.
But yes, it is has been taken into consideration.
Exciting stuff, though, whichever way you cut it. Maven, after its 10-month journey and the options it has to investigate the the evolution and the history of the Mars atmosphere. I mean, there's been an awful lot of emphasis over the last several years on ground-based activity. You know, the Mir rovers, Curiosity, and so on. Everybody has sort of been wanting to get down onto the surface, dig around, play in the mud, play in the sand, all that sort of good stuff. And yeah, there's great stuff down there. But a lot of the story of the Mars, of the planet's evolution, lies in the atmosphere, going from relatively thick to almost non-existent. So MAVEN really does have a terrific opportunity to add significantly to the evolutionary story of Mars as a planet.
Well, yeah, there's not only is what MAVEN will be producing can add to that, but I just actually saw in the archive when I was looking for stories for this show. Actually, I saw that they've recently released, or a team has recently released, an 8-year compilation of dust patterns and opacities in an entire map of Mars surface. We've got 8, and the former astronomer in me, just loves the idea of a data set this big, but we've got 8 years now of optical depths all around the planet's surface, which should let us characterize the dust activity both in years of superstorms, super Martian dust storms, which tend to cover the entire planet, as well as more regular years in which you can see how the different surface temperatures and wind conditions affect prevailing dust conditions in the Martian atmosphere. So I thought that was really cool. Unfortunately, I didn't think there was enough there to make a story out of it, but figured that it was worth at least a slight mention.
Well, whichever way you look at it, all of the missions, and we've got many now that have got terrific longevity, are not rewriting, but they're adding significantly to the story of Mars's past. I mean, there's the European Space Agency's Mars Observer, or Mars Odyssey, gosh, what does it used to call its Mars probe? Mars Express. There we go, Mars Express. We do have Odyssey. We've got the Mars Reconnaissance Observer. We've now got MAVEN. All of them have got such long and rich histories of contributing to the story of the Martian environment that you just can't help but drool for the scientists who are working hard on Mars.
Well, speaking of people who are working hard on Mars, MAVEN will hopefully not be the only orbiter mission to arrive around Mars this week.
Right, back to Julie.
Sorry?
Oh, okay. I thought Julie was going to carry on with part 2.
Nope. The second mission, well, I'll get and then we'll all have a discussion.
Okay.
So,
I'll read my notes a little more carefully. I'm sorry.
So the Indian Space Agency, their mission to Mars, the Mars orbiter, MOM, will arrive hopefully later this week. They'll be deploying an engine burn for 24 minutes on Tuesday, tomorrow, around 10 p.m. Eastern Time. And they'll be trying to slow the craft down to nestle it safely in orbit around Mars. This is going to be a crucial operation, which is going to be made trickier by the fact that they are going to be in the dark, meaning they are behind the planet, both in terms of position from Earth and position from the sun. So the entire operation will have to be performed communicationless, which is not that big of a deal because obviously Mars is about 7 light minutes away from Earth, so any kind of communication wouldn't really help in any kind of orbital maneuver. However, it will be in the dark behind the planet, meaning that all of this operation must be performed on battery power. There is no recourse to solar power should something go wrong. And I'm sure that won't be an issue, but the engineer inside me just cringes every time I see that something needs to be done on exclusively battery power. However, if they are successful, this will make them the 4th country, only the 4th country, to put an orbiting satellite around Mars. They will be studying particles in the upper reaches of the Mars atmosphere. They'll be watching the particles as they respond from activity to the sun. These particles are, of course, much more susceptible to solar activity than the same particles would be here on Earth, since Mars does not have a strong magnetic field to shield it from solar radiation. Of course, our own magnetic field here on Earth is a big sort of protective guard which causes solar radiation to fly off and curl upwards away from Earth, keeping us all safe and our atmosphere, more importantly, safe from the damaging effects of the sun, much like sunscreen would keep Paul's skin safe from the damaging effects of the sun.
All for that, yes. Go sunscreen, yes.
The final orbit of Mom will be a 3-day elliptical orbit with a periapsis of about 423 kilometers, or 262 miles. I should really stop doing the units in both miles and kilometers. See my own personal protest against non-SI units. At any rate,
editing the notes right now. Yes, not a problem.
Yeah. The periapsis will be at 423 kilometers, and hopefully everything will run smoothly. An engine test was conducted earlier today, and everything seems to be working correctly. But Mom has experienced engine trouble before when it was performing apogee increasing burns in order to achieve a transfer orbit to Mars. And I actually reported on that back in, I think, it was earlier this summer, or it might have been in the spring when the mission was launched. But they missed one.
It was November.
Was it November?
Yep. Time flies when you're having fun, Hugh.
I suppose it does. Well, okay, so they missed. Unfortunately, they missed one of their essentially as the satellite goes around the Earth, it fires every time it gets closest to the Earth. In a fun little quirk of mathematics, that just turns out to be the most efficient place to change your orbit, is when you're closest to the Earth, or closest to Mars in this case. But unfortunately, they missed one of their burns at that time, and they managed to rectify the situation and achieve their transfer orbit eventually. But I'm fingers crossed that such a thing doesn't happen again, because unlike the apogee increasing burns which occur around Earth, there is really only one opportunity to get this one correct. But still, should be fun. That will happen tomorrow night. So fingers crossed, everybody.
Yeah, the spacecraft Magdalene, I think, is the official name for it. It's really quite a piece of engineering from the Indian Space Agency. And as you say, Hugh, they get one shot at orbital insertion. They've got to slow the vehicle down by this continuous firing of the engine in the opposite direction to the direction of travel, so that the gravitational field of Mars will be able to snare the spacecraft and put it into the orbit. It's been a very successful mission to date, and as you say, it'll be the fourth country that has managed to do this. Japan, JAXA, is often thought of as sort of the next major power, shall we say, as far as spacecraft is concerned. But they launched a spacecraft called Nozomi many years ago, and it failed to fire its engine. Its onboard fuel, if memory serves, froze, and they were unable to use that fuel to fire the engine, and the spacecraft went sailing by Mars. So, yeah, there'll be a lot of anxious moments tomorrow as the engine lights up and hopefully holds its nerve and holds its thrust for the required amount of time. Otherwise, this spacecraft too will have a very brief encounter with Mars, which will be very sad. Not a fitting end for what has been to date a very good mission for the Indian Space Agency.
Yeah, no kidding. Well, it's certainly a huge technical challenge, and I'm really looking forward to tomorrow night. I'm really holding out hope that it'll work.
Mm-hmm.
I think it will. It'd be nice to see. Sorry, go ahead.
No. Finish your thought.
I was just going to say, it's nice to see, another space agency essentially breaking into that club. I mean, it's insane. I realize the magnitude of the technical challenge involved, but it's still insane to me that only 3 groups have successfully managed to put something in and around Mars.
It's a hard place to get to. I mean, you only have to look at the track record of NASA as well as the Soviet Union / Russia. I mean, they're barely batting 500 using baseball terminology here. It's a
I
tough
think
tough
NASA's the
challenge.
only one who's batting 500. I don't think the Russian space agency is, and nor is ESA.
No, that is very true. The other comment too, by the way, with respect to the science mission, is the ability of the spacecraft to look very specific. Try that again. Very specifically for methane. That is one of the primary mission objectives, to try and better understand the distribution of methane that exists around Mars. There's been great controversy over the last probably 30 years with a variety of measurements of methane concentration. Is it in pockets? Is it continuous? This spacecraft will have the ability to hopefully iron that discussion out, and we end up with the ability to say, yeah, biology versus geology in the production of methane. We'll have to see.
Well, speaking of new measurements that we're looking forward to, another measurement which we have been looking forward to was just recently released. Paul, I think you have some information for us.
Well, it's a bit of an update on an older discussion that we spoke about, I guess, some 6 months ago, roughly speaking, and it's the Planck probe. You may recall that back all the way on March 17th, we spoke about this in an announcement made by the BICEP-2 team, and I keep forgetting what BICEP-2 stands for, but it doesn't really matter. It's basically the data analysis team from Planck. They'd found various polarizations of light from the cosmic microwave background radiation, or at least what they attributed to the CMB. These polarization signatures appeared as wonderful little waves. They surmised that was caused by gravitational waves, evidence supporting the theory of inflation. And of course, if you think back to your cosmology, the earliest moments in the universe when the universe expanded furiously and froze in these various gravitational waves, we think we can see that measured or measurable by the polarization of light from those earliest moments in time. As you can well imagine, there was much debate in the scientific circles in the days that followed this announcement, in fact, in the weeks and months that followed that announcement, as to whether or not the polarization was actually being caused by gravitational waves or by the foreground dust that is known to cause a similar effect. We're looking backwards in time, back 13.8-ish billion years, but we've got to look through the here and now, and the here and now contains a significant amount of dust, and that dust, of course, is resident inside our own galaxy. And so there was a lot of discussion about whether or not what we were looking at in the Planck measurements was in fact caused by the foreground dust measurements, because of course dust generates polarization, or whether or not we were really looking at the telltale signals associated with inflation. Separate team working on this very same problem using ESA's Planck Space Telescope was not ready to release their data at that time, and people have been waiting to compare the two results ever since. Well, late last week, the Planck team published a dust map that suggests that the majority of the BICEP-2 signal was indeed due to foreground dust. Okay, you can see the battle lines being drawn here. Everybody is raising their calculators, their slide rules, their pens, and their pencils, ready to do battle. More analysis is needed. No surprise there, as the two teams have been working together since July to try and figure out what the heck is going on. Stay tuned, because the next update is due in November. I mean, this to me is a rather neat story, because, of course, we wanted the BICEP-2 results to tell us that it was gravitational waves, that it was inflation, that what we were seeing really was what we were hoping for in those early signatures of the universe's inflationary expansion. But now there is a lot more than a little doubt about that interpretation. And, dust was always suspected to be a problem I guess there was perhaps a little too much wishful thinking in March to think that the dust wasn't the problem.
Yeah, they sort of assumed it away.
Yeah.
Is how it was described to me by a friend in the astrophysics department. They sort of assumed, because of the relatively low dust levels in the area of the night sky that they were observing, that it wouldn't be an issue. But there's a particularly telling quote from Brian Keating, one of the astrophysicists who worked on the BICEP project, which I found quite funny when I read it. And that is that the quote is referring to the Planck data, that it is relatively definitive in that we can't exclude that the entirety of our signal is from dust. Because the Planck data really does show that it could be as much as 100% of the, like a full 100% of the BICEP results may in fact be dust. So as you rightly say, Paul, more analysis is needed, but it is not looking good.
Well, I mean, this is why data goes out into the public domain, why there is such a thing as peer review. The data analysis that came out in March was not unreasonable, but it put everybody on notice, and lots of groups went out there and said, okay, what if? And now we've come out with, the what if is really maybe this is what's going on. So I don't have a problem with this playing out as it has done. I would certainly prefer people to go at the data with great energy to really pin down which is the correct answer, rather than one group just rolling over and saying, okay, you're right, that's fine, and go at it from there. So it's just the way science is. You've got a set of data and there are multiple interpretations. Let the teams go at it, and if another team wants to go at it as well, until we are sure that we understand what the data is telling us.
An interesting aspect as far as the scientific process and the public understanding of science and the scientific process. There's a Washington Post article that I read, which is linked to in the show notes, that was talking about this and mentioned that the announcement was made before the peer review was done.
Yes, and that is what people mostly took exception to.
I didn't realize that was the timing. The announcement was before the peer review was concluded, eh?
Mm-hmm.
Exactly. Yeah.
That's a no-no. I actually did not know that. I thought that the announcement came out after the peer review had been completed, but maybe prior to the publication, but the peer review process had completed, and sometimes then there's a little bit of delay before you get to publishing. But it was actually completed before peer review. Well, that reeks of things like cold fusion, doesn't it?
Well, it's a competitive environment. You need to get enough grant money for your project. You need to drive public engagement. There's a fine line, perhaps, between effective marketing of your institution and good science. And perhaps on this side they were on the wrong side of it. But
well, as I say, the science was reasonable. I mean, their conclusions were not unreasonable. But you really should follow the rules here, otherwise you get us all into trouble, because the news media jumps all over these things. And
scientific ethics are as important as any other aspect.
Absolutely. And by the way, Julie has very meticulously gone out and found out what BICEP stands for: Background Imaging of Cosmic Extragalactic Polarization. I'm not surprised I didn't remember it. So anyway, that's what BICEP from the BICEP 2 team refers to. So I guess we're going to be returning to this story in November, is the bottom line to this. There are more issues to be released.
Indeed. All right, our final news story of the night, which we're going to have to unfortunately go through quickly, is that the landing site for Rosetta's Philae lander has been selected. They've selected the aptly named Site J, which is a I don't know if it's aptly named. I just like to poke fun at their naming schemes. In fact, I think ESA has a competition now for members of the public to name the landing site. So that's interesting. If you go to their website, I believe you can participate in a competition to name the landing site for
Public
the
engagement, as you were just talking about.
Exactly. At any rate, the landing site has been selected. It is an area on the smaller of the two lobes of the comet. For anyone who hasn't had time to look at it yet, the comet is essentially shaped like a dumbbell. It's a really oddly shaped object. Now, the site they've chosen has a good amount of sun exposure, so power shouldn't be an issue for the lander, but it's also only 500 meters away from one of the areas of the comet that is expected to become highly active with vents and outgassing as the comet moves closer to the sun and as it heats up. The landing itself is going to be exceptionally tricky. And we're very lucky, in fact, when landing on planets like Mars, in that they have a uniform mass distribution. They're a nice sphere. It's very easy to model the gravitational field for an object like that. But this comet, which, as I mentioned, is dumbbell-shaped, which has two different lobes, different sizes, you have to be very careful about how you model the kinematics of this system. In fact, the comet itself looks exactly like what old physics professors of mine used to draw on the board when they wanted to indicate amorphous masses in which we'd have to work out the center of mass. The descent itself, and this is the crazy part, is a passive descent, meaning that the lander will be released onto a ballistic trajectory, a fancy rocket science term here for falling, towards the comet. And the descent time is 7 hours. So it's crucial that the satellite land with the minimum amount of force, as the escape velocity of the comet is less than human walking speed. So the fact that it's a passive descent means that the selection of the landing site is crucial. Because when we land missions like this, or like any of the missions on Mars, there's a certain amount of uncertainty involved in the landing process. So engineers like to use what we call a landing ellipse, which describes with roughly 99% probability where the lander is likely to arrive. But more specifically than that circle that we inscribe on the map, we can't really say. So the ESA, the European Space Agency, assessed each site using a square kilometer and examined the number of boulders in the site as well as the percentage of the site with a terrain slope of over 30 degrees. This is important because really when you have a passive descent like this, it's like trying to fire a cannonball through a forest. This is how I described it to Paul earlier in the night. Like trying to fire a cannonball through a forest in which all of the trees are magnetic. You need to model perfectly the path that the lander is going to take between the two lobes as it navigates through the gravitational field. And not only that, you are then stuck with mere probability when it comes to hitting the landing spot. There may be a boulder exactly where it's going to fall down. So when you pick the site, you need to pick the barest surface, and you need to pick the